Hi, I'm John Maher. I'm with Reset. We're a nonprofit that gets kids excited about science and math learning through hands-on STEM activities. We're in shutdown right now because of the virus in the year 2020. So we're encouraging people at home to work with children on science experiments using items that you may find around the household. So today we're going to be talking about liquid density and what you need, a teaspoon, salt, corn syrup, vegetable oil, 3 kinds of food coloring, and 4 small containers. And in the back here I have 2 glasses of water, one of which must be transparent. I have a container of warm water that I heated up in the microwave, and an eyedropper. So what we're going to do, we're going to start by pouring some of the liquids, this is the corn syrup, into these small containers here. And this is the vegetable oil. And put some cold water in this one. And we'll just leave this one empty for now. That's for the hot water. We'll just let that stay in its thermal container. I'm going to add a teaspoon of salt to this container of cold water here. And then I'm going to stir it. It takes a while for the salt to dissolve. So if you saw the earlier video about floating and sinking where we use solid objects, if you remember, the smaller golf ball sank and the larger baseball floated. And we introduced the concept of density. The golf ball being a higher density object and the baseball a lower density object. For the younger children, we just say it's a combination of the weight and the shape that influences whether it'll float or sink, since density can be kind of a complicated topic. And now we're going to work with liquid densities. So in the water I just added the salt, I'm going to put in red food coloring. In the vegetable oil, I'm going to put, in between, I'm going to clean this thing in the other glass of water so we don't mix colors. So in the corn oil, we now have blue. I'm going to leave the vegetable oil, the corn syrup. I'm going to leave the vegetable oil alone because it's yellow in color, plus food coloring doesn't mix with it. I'm going to clean off the corn syrup. Now, one by one, I'm going to introduce these mixtures, these colored liquids, into this transparent glass of cold water. And this has to be done carefully because if the water is mixed too much, it doesn't sort out the layers. So starting with this red salt water, observe where that goes. This is a eyedropper where you squeeze the bulb, put it in the liquid, and then release it to make it work. I'm going to clean this guy. And now I'm going to, I'll move on to the vegetable oil. Again, you just put it very tip of the surface and put it gently so you don't mix the liquids. We just want to see where they naturally sort out here. Now I'll mix the hot water here. Add some green food coloring. And introduce it the same way. And finally, I'll add the corn syrup. I do that last because this is kind of sticky and kind of contaminates your eyedropper, hard to clean. Again, introducing each liquid gently right at the interface of the top of the water and the air so that it doesn't agitate the water and mix things up. All right, and now you'll have your child observe where they see the various colors in this mixture. So the green representing the vegetable oil is right at the top. The yellow kind of merged with the green. That is the vegetable oil, and the hot water float at the top. At the very bottom is the corn syrup, colored blue, if you can see that. And then above that is the reddish salt water. So what we can conclude from this is that the density of the corn syrup is very high, meaning its weight is heavier than that of water. It sinks to the bottom. Salt water is heavier than fresh water, so since this glass we started with is fresh water, it goes to the bottom. And then the hot water is lower density and goes to the top, and oil is low density, so that also remains at the top of the column of liquids. So that's why when there are oil spills, that oil floats at the top of the bay or the ocean or wherever that spill occurs. Salt water has a higher density than fresh water, and therefore it also has a higher buoyancy force and pushes up more. So you'll find that things float easier in the ocean than they do, say, in a swimming pool or a bathtub. So the basic thing here is that the liquids have the same properties when it comes to floating and sinking as do solids. And this experiment is to demonstrate how different densities affect how they float or they sink. I'm going to again take a quick video of the tadpoles that I've been doing at the end of each session, watch them develop over the weeks. Before I do that, I'm just going to try hold this a little closer with a white background. Maybe it'll be better visible in terms of the stratification of the colors. So these are the tadpoles from my garden pond. I'll take some still photos so you get a better sense of what's going on. But they seem to be a bit bigger than they were last week. This here piece of tape on the container is 1 inch, and I think some of them are approaching 1.5 inches or so. And then when you see the still photos, we'll see if we can notice the development of the appendages. I also notice a red color on some of the tadpoles that I've never seen before. I have to look that up and see if that indicates what kind of frog they are.